Hello there, myself is Nuren Abreshum Anonta, ID 222902092, and today I am going to explain about vast concept of machine learning and data mining. So, focusing on decision trees, model evaluation methods, and clustering techniques. Firstly, decision trees and the Gini index. Addition trees is essentially a structured way of making decisions. At each step, we ask a question about the data, and based on the answer, we moved in a particular direction. Very similar to how humans make decisions in real life. Now, the important question is, how does the tree decide where to split the data? For that we use something called an impurity measure, and one of the most commonly used measures is the Gini index. The Gini index tells us how mixed the classes are in a node. If a node contains only one class, the Gini value is 0, meaning it is perfectly pure. And let me explain this with a numerical example. Here we can see, suppose we have a dataset with 8 samples of a class A, 5 samples of class B. In total we have 13 samples. First, we convert these counts into probabilities. The probability of class A is 8 divided by 13, and the class B is 5 divided by 13. Once we have the probabilities, we square them and substitute them into the Gini formula. We subtract the sum of squared probabilities from 1. When we do this calculation, the final Gini value comes out to be approximately 0.47. What does this tells us? It tells us that the node is not perfectly pure, but still reasonably informative. In practice, when building a decision tree, we compare Gini values across possible splits and select the split that produces the lowest Gini index, because that split gives us the cleanest separation of classes. Now next move on the tree splitting and tree pruning. Now that we understand how a split is evaluated, let's talk about the tree splitting and pruning. Tree splitting is simply the process of dividing data at a node based on a feature that improves class separation. However, there is a risk here. If we allow the tree to keep splitting without control, it may start learning patterns that exist only in the training data. This problem is called overfitting. To handle this, we use tree pruning. Pruning helps us simplify the tree by removing branches that do not contribute much to prediction accuracy. This improves performance on unseen data and makes the model easier to interpret. Holdout method, where we split the dataset into training and testing portions. However, this approach can be unreliable if the dataset is small. In cross-validation, where the data is divided into multiple parts and the model is trained and tested multiple times, this gives a more stable estimate of performance. And another powerful technique is the bootstrap method, which creates the multiple training datasets by sampling with replacement. Those all are the model evaluation techniques. Here more about the bootstraps method, which can create the multiple training datasets by sampling with replacement. This method is especially useful when we want to measure model variability. And let's move the unsupervised learning, especially cluster analysis. Cluster analysis groups data points based on similarity without using class levels. For categorical data, traditional algorithms like k-means do not work well here. This is where k-modes clustering becomes useful. Instead, using numerical distance, k-modes compares categorical mismatches and represent each cluster using a mode. Assume we have objects described by color and shape, and we want to form two clusters. We start by choosing two initial modes. Then for each object we count how many attributes do not match each mode. The object is assigned to cluster with the minimum number of mismatches. Through this process, k-modes effectively groups categorical data in the logical data interpretable way. Here we can see the examples. We assume that there are three objects and several colors. We initialize the modes, and then we have seen the mismatches and the matches require us predefine the numbers of clusters. Instead, it builds a hierarchy in agglomerative clustering. We start with individual data points and gradually merge them. In divisive clustering, we start with one large cluster and keep splitting it. The result is visualized to use a dendrogram, which is help us understand how clusters are formed and decide where to cut the hierarchy. So here are some advantages and disadvantages shown in the text. So that's all from me, all from my presentation. Thank you.